time last year I was standing at this rather beautiful spot on the island of Herm, looking back across the Guernsey, and I made a little physics video about this little hole in the ground just up ahead, a pit that leads down to the sea below, and there's a sign on the pit that says it's 20 meters deep. And so last year I made a little video showing that it really is 20 meters deep just by timing how long it takes a rock to get to the bottom. And at the end of that video I said make sure no one's standing at the bottom of the hole, because I'll get rather a nasty headache if they're still standing there when a rock arrives. And so this year I thought I'd shoot another little physicsy video using another of the famous formulae of physics to actually show quite how fast the rock really would be going when it reached the bottom of the hole. Last year we used this equation to time how long it took a rock to get to the bottom of the hole, and hence figure out that it really was 20 meters deep. This year we're going to use another of these sets of equations that gets used quite often, v squared equals u squared plus 2as, to figure out quite how fast the rock was going when it got to the bottom of the hole. So there's various ways that you can derive this equation. The simplest is just to think in terms of kinetic energy and potential energy. The kinetic energy of the rock when it gets to the bottom of the hole, half mv squared, is whatever its kinetic energy was when it started, half mu squared, plus the energy that got converted from potential energy to kinetic energy as it fell down the hole. So that's this formula mgh, the formula for potential energy. And you can see that's just the same as the formula above. If we just cancel through the equation, get rid of the m's on both sides of the equations, multiply both sides through by 2, so that gets rid of the halves, then we end up with 2 times g times h, which is just the same as 2as, because in this case a is the acceleration due to gravity g, and s is h, just the depth of the hole. So if we plug some numbers in, the initial speed was 0 because we just dropped a rock. Acceleration is just the acceleration due to gravity, which is about 10 meters per second squared. The depth of the hole, as we saw last year, is 20 meters. Plug all that lot in, we end up with that v squared is equal to 0 squared plus 2 times 10 times 20, which is 400 meters squared per second squared. If we take the square root of that, we end up with the rock traveling at about 20 meters per second when it hits the bottom of the hole. Now, roughly speaking, the conversion from meters per second to miles per hour is about a factor of 2, a little more. So that means that actually the rock would be going at more than 40 miles an hour when it gets to the bottom of the hole, which really means you don't want to be standing at the bottom of the hole when that rock arrives.